Hello, everyone. Today we continue our discussion of right triangles, and we're going to discuss trigonometry. Trigonometry is the study of relationships among the angles and sides of triangles. A trigonometric ratio is a ratio that compares the side lengths of the two sides of a right triangle. The most common trigonometric ratios are sine, cosine, and tangent. So when we have a right triangle, what's very important is that you need to identify the different parts of the right triangle. So in all of our examples here, we're talking about angle A. So here is angle A. So in terms of our right triangle, the hypotenuse is always across from the right angle. And then the other two legs we associate in terms of what angle we're talking about. So here it says sine of A, cosine of A, tangent of A. So that means we're talking about A. So if we're talking about A, the side across from it, which is little leg, is our opposite. And the side that's next to it, which is little b in this case, is our adjacent. So the sine of A is the opposite leg over the hypotenuse. So I always write it as O over H. The cosine of A is the adjacent leg over the hypotenuse, or A over H. And the tangent is our opposite leg over our adjacent leg. So that's O over A. There's this acronym SOHCAHTOA to help us remember it. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now to find the missing side length, and use the side lengths to write the trigonometric ratios. So you're going to find B by using the Pythagorean theorem. So pause and find B and come back. Okay, so I did the Pythagorean theorem because C is the right angle, so the hypotenuse is 15, it's across from the right angle. I found out that B is 12. So now that I know B is 12, I see that all of my ratios are talking about angle A. So here's angle A. The hypotenuse is always the hypotenuse. So then across from angle A is 9. 9 is the opposite. And next angle A is 12, so that is the adjacent. Now sine of angle A is the opposite side over the hypotenuse. So our opposite length is 9, and our hypotenuse is 15. So the sine of A is 9 over 15. Cosine is adjacent over hypotenuse. So our adjacent side is 12 over our hypotenuse, which is 15. Our tangent is opposite over adjacent. So our opposite side is 9, and our adjacent side is 12. So that's 9 over 12. Those are the three trig ratios for angle A. So now I want you to pause. I want you to find the three trig ratios for angle A for 1, 2, and 3. And then come back and we'll check. So the first thing I do on number 1 is I label my parts. So here's my right angle. So this is my hypotenuse. I'm talking about angle A. I could talk about others, but in this case I'm talking about A. So 24 is my opposite and 7 is my adjacent. So sine of A, and I always have to say what angle I'm doing because I could do B, is opposite over hypotenuse. So that's 24 over 25. Cosine of A is adjacent over hypotenuse. So that's 7 over 25. And tangent of A is opposite over adjacent. So that's 24 over 7. Do the same thing for number 2. So across from C is our hypotenuse. Here's angle A. So 4 is adjacent and 3 is opposite. So sine of A is opposite over hypotenuse. So it's 3 over 5. Cosine of A is adjacent over hypotenuse. So it's 4 over 5. And tangent of A is opposite over adjacent. So that's 3 over 4. Number 3, before I can do it, I need to find my hypotenuse. So I'm going to do the Pythagorean theorem. A squared plus b squared equals c squared. So it's 8 squared plus 12 squared equals c squared. So it's the square root of 208. That is not a perfect square, so I'm going to look for my perfect square factors, which perfect square factor in 208 is 16. So it's 16 times 13 equals c. So that's 4 radical 13. I'm going to write that as 4 radical 13. Now I'm going to do so here it said angle A, but this triangle doesn't have an angle A. So let's actually do it for y. So C is my hypotenuse, 12 is opposite, 8 is adjacent. So the sine of y is opposite over hypotenuse, so it's 12 over 4 radical 13, which you can leave it, which we need to simplify. So we multiply by radical 13. So that's 12 radical 13 over 4 times 13. Actually, before I do that, I'm going to divide 12 by 4 and say 3. So it's 3 radical 13 over 13. Now the cosine of y is adjacent over hypotenuse. So that's 8 over 4 radical 13. Again, 4 goes into 8 2 times. Then I multiply by radical 13 over radical 13. So that's 2 radical 13 over 13. Then tangent of y is opposite over adjacent. So that's 12 over 8. I always leave a trig ratio as a fraction. It's a ratio. So now to find the missing lengths. I need to decide which trig ratio I'm going to use. And here we're going to actually be using our calculator. So let's take a minute to talk about what our calculator is doing. So all of our trig ratios are a constant depending on the angle. So when you're looking at your calculator, first of all, we need to make sure we're in degrees because all of our angles are going to be in degrees. So we're going to go to mode, and then on your mode, you can see that the fourth one down currently says radians. We're going to arrow down, and then we're going to arrow over to degrees and hit enter. And then to get out of mode, you do second, quit. Okay, now you will see that we have a sine, cosine, and tangent button. And I just realized you can't see my calculator. So I'm going to end the video there and start another one where we're finding the missing sets.